Okay, how about this one?
Was it 45 minutes?
Yep, that's it. That's weird. Okay, how about these?
Is the median 37?
Yep. And how about part B for the bottom
one? Is it? Is it 12?
Yes. 50 to 12. It's fine. Okay, how do we do this?
Is the median weight something like 128?
Let's see. Yes. I think that's good. And as always, just use your ruler. It's 8 grams. Yep. Okay, complete the table.
So is it 4 and then 11?
Yep.
And then 24? 36? 42?
That's it. Fine. Fine. So, and this was median. Let me just click over here. Okay, so cumulative frequency. Let me see. All right, well, I'll start with. No. Let me. All right, better do it. Okay, how about this?
So So is one possibility of the cards to be like 4 and 6?
Yeah. And another.
Yeah. Um, 3 and 7.
Yeah, exactly. So not difficult, not a difficult idea, but just having to unpick all the stuff. Sorry, this one.
Is it 60 to 80?
Yeah, that's fine. Median. We did this stuff, I believe. Median.
6.
Grand. Hang on. Oh, I better do it. Mode.
Probably 13.
Yeah. Okay. Good. Mode for this one.
1.
Yeah. Just checking that is. Okay. Speed. Let me just click on this thing again. Mode. This one, what is the range?
Is the range 0.14?
Yep. Let me just. This one. Okay, how about these two?
Okay. So 18,
Mm-hmm.
11, 7, 3, 1. And then do I just need to add up all the frequency and then that'll tell me?
Yeah, that's it. And I think that's fine. I think it's 50. Just checking that you know that that's what you have to do. Oh, it was 40. There you go. Okay. Okay, how about this one?
Is it 2?
Yes. That one's fine. Okay, how about this one?
Is it 1.5 to 1.6?
1.5. So let me just H 1.6. Oh, so it's 35 people. 35 plus 1 over 2 is the 18th person. They're not in there. What would be cumulative frequency for this one? So if you're doing cumulative frequency?
Was it 20?
Yeah. And so how did you get your answer?
I just guessed it because 7 was in the middle. It was that.
Okay, so 35 girls. In total, there's like n plus 1 over 2, so it'll be the 18th person. Where is the 18th person?
In the 1.4 to 1.5 bit.
Yeah, so this is how median works for this. And you can imagine if they wrote this out the long way, like 1.3, 1.31, 1.32, or whatever it might be, and they did that. So 1.40. So this is summarized data. They summarized it into a table, and then you just get it out of it. Is that exactly the same? Yeah. Okay, how about these?
Do you mark that around 0?
Yeah, so that's on 0.
And then do you need to mark a quarter of?
And where would that be? If you have half in the middle?
Half of the half.
Yeah. Okay, fine. All right, this one.
Huh? Is it D?
It's D. There we go. I'm gonna say you're gonna be fine for these. There's lots of words and stuff. Even number. I'm just gonna skip over this stuff. I don't think it's a good use of time. Evens is like half. Likely, unlikely, certain, impossible. Let me just go back a second. Okay. Okay, two-way table, part A.
Winter.
Yeah. Part B.
Amaryllis.
That's fine. There's one. Okay, how about C, part 1?
So do I need to do like a sixth of on that scale?
If why is that?
Because in the planting season bit has like winter is like 6 different seasons.
It has a flowering season in winter.
All right. Oh, right. Oh, would it just be like 0?
So it's 0. Yeah, that's it. And so how about the last one?
I think that's half.
Yep, that's it. So those ones, it's just about unpicking the words. Okay, how about this one?
You need at least like 2 more blues.
Blue. And so could the last one be red?
No, the last one has to be blue as well.
Yeah, because then it would end up being even. Okay. Fine. Or, all right, how about this one?
Um, 1.
Yeah, so just making sure. 1.0, 100%. That won't give you any trouble. Let me just make sure. Okay, you're gonna be fine there. Okay, how about this one?
So do I need to do like 2 times 6?
So there will be 12 outcomes, but what are those outcomes?
So it could be like 1 heads, 1 tails. No.
Yeah.
2 heads, 2 tails.
Yeah.
3 heads. It just goes on like that up to 6.
Yeah, exactly. 5, 6, fine. So that's what this is asking for, all the possible combinations. So there's 12 combinations, and yeah, so here's one, and they did the first one for you. Head 1, and you just go from there. Theoretical probability. All right, let's try these.
Is it 7 over 18?
Mm-hmm.
12 over 18?
Yeah.
0 over 18.
Yes. That's fine. This one.
0.8.
Okay. How about this?
Would it be like tails equals to half X or something?
It's a biased coin. So a second ago, we said in a biased coin, if heads is 0.2, then tails is 0.8. In a biased coin, if heads is X, then what is tails?
would that tails be like 0.6 x equals to 0.6 tails?
So let's say you have heads and tails. So a second ago you said that's 0.2, so that must be 0.8. What if heads was 0.3?
0.7.
What if this was 0.6?
0.4.
And so that's x. What is it that you're doing to get it?
You're adding up the two numbers so they go to 1.
Yeah, and so let's say 0.2 plus 0.8 is 1. We're trying to, so that one's heads plus tails equals 1. So what is tails?
1 minus h.
And in this case, what will it be?
1 minus x.
Yeah. So the answer is, so if heads is x, then tails is 1 minus x. And that's the way you're going about it. That's all right. It's okay. Okay. How about these, B and C?
Is it 0.4 for B?
Yeah, that's all it is. And C.
It'll just be like 1 minus 0.3 minus 0.1 minus like y or something equals to x.
That it lands on a 3?
Yeah. Oh, right. It's just a quarter.
Nope. We don't know what x is. How would you get the probability or the number of times it would land on a 4?
You would do 0.1 times 300.
So probability of a 4, or number of times for a 4, would be 0.1 times 300. So how about probability for or number of times for a 3?
X times 300.
Yeah. And can you write that in a shorter way?
300x.
Yeah. That's it. 300x. All right. We'll do one of these.
Oh. 7/10.
Okay, how do we go about this one?
Okay, so I need to do A.
Sorry?
Yeah, sorry, so I need to do A.
Yeah, so just how would you do it?
So would you just whereas like 1 and 8, it would be like 9, and then for 1 9 it'd be 10.
That's fine. And then part B, what is the probability that a score is greater than 12? It would just be the numbers that are bigger than 12 over the total.
Okay.
Okay. Let me just come back to this one. Oh, no, spoke too soon. Right, we're doing it.
Okay, so for lose, is it 1 minus P?
Yeah.
And then to win after, is it just P? Alright, so to lose, then it's 1 minus P again.
So that's 1 minus P. The probability that you win any game of snooker is P. Just plays 2 games of snooker. Okay, and then these ones down here?
And then P, and then 1 minus P.
That's P, that's 1 minus P. Okay, how about part C?
Okay. A quarter P.
No. What is it? So just because there's 4 outcomes or something doesn't mean they're all going to be equally likely. How could she potentially, what are the combinations for her to win 1 game if she plays 2 games?
2P.
So like the combinations would be she wins the first one and she loses the second one.
Yeah.
Any other possibility?
She loses the first one and wins the second one.
Yeah. And so that's the possibilities for her to win 1 game, because if she did win, then that's 2 games. Lose, that'd be 0. So you find these 2 probabilities, and what would you do with them?
Would you times them together?
You add them. So in an earlier question, there was like a 0.3 and a 0.1. What's the probability that they get a 1 or a 4? And in total, it was 0.4 because you just add them. And when the question has or, so like win or lose, then it's going to be your add type. If it's both, like she wins both, then it's a times type. Okay, what's the probability that she wins and then loses?
So P and then 1 minus P.
Yeah, and so you multiply across.
So that would be like P minus P squared or something.
Yeah. And then probability that she loses and then wins.
Will it be the same?
So I believe it is the same. And so that's P
minus P squared.
P squared. And so in total?
2P minus 2P squared.
Well done. Squared. And I think the quick way is you find one of them and double it, because in this case it was the same probabilities for both. Okay, any questions there?
So what about the probability that she wins both games?
Say it again, sorry?
So where it says the probability that she'll win exact. Oh no, sorry, I've read the question wrong. No, sorry, don't worry.
Yeah. No, you've scared me. I thought for a second, I was like, oh, is it she wins both games? That'd be much easier. What's the probability she wins both games?
2P.
No. You multiply across. So P plus P is 2P.
Yeah. Oh, P squared.
P squared. Yeah, that's fine. Okay. Okay. Believe it's calculator. How do we do this?
So I need to like 0.025 times 2,800, and then to the power of something.
Very close. Because you're adding on 2.5 each time. It's not 0 point, it's 1 point.
Oh, right, okay.
0.025, and it's times 10 to the something. Times that to the power of something gives you greater than 3,000. So you just check different numbers until you find one.
Yeah. Yeah.
Do you have a calculator?
No, sorry.
Okay. 5 to the power of alpha x. So this is my fancy way of doing it. Start with 1. Let's stop at 10. Go up by 1 each time. So this is just substituting them all in. Like the power is 1, 2, 3, 4. So what is n for this one?
3.
Yeah, n equals 3. And the long way would be just type in the whole thing that I've written out there and change it. 1 equals 2 equals 3 equals. Okay, so how do we go about this one?
So do I need to do 0.8
right
times 27,500, and then to the power of something to get.
So you have it a bit backwards. It's the percentage that's to the power of. So that's the initial amount times 0.8 to the power of n.
Times. Oh, right.
And we have to get 1, 1, 2, 6, 4 this time. So let's just do it the quick way. So you can see their mode table if you ever want to try it. So you put in the starting amount first, then times by the change, and then to the power of, and you can try in different things. I'll just do alpha right bracket, which is x. Start with 1, stop at 10. Step there. Okay, so when is this 11,264?
After 4 years.
So what's the answer?
N is 4.
Yeah. Okay, what's the working out for this one?
So, is this like, say 2,500?
Mm-hmm.
The power of n.
You did it again.
to the power of times 0.03 to the power of n.
Close. What should be here?
Or 1.
Yes. Okay, and then you just sub in different things for n. Oh, sorry. That's going to be equal to 2813.77. And you could just go from there. What would you put into your calculator for this one?
So do you just need to do 500 times 1.025 to the power of 12?
That's all there is to it. Extension question. What percentage increase is this?
What percentage? Is it 2.5%?
Yeah, that's it. Good. Okay, how do we do this?
So to do this, can you do like well, this is a very short way, but could you do 221 over 260 times 100, and that'll give you and then you just subtract that percentage from 100.
No, that's the final answer there, I believe.
Oh.
It's change over original times by 100. And so if it's a calculator question, I would even just do that. Wouldn't even try to work it out. Over 260. So that's how much it changed by. That's that times 100. And that gives us the reduction as a percentage. Yeah. So the first bit gives... Hang on, the reduction. No. It's reduced by £39. So you don't even need to do that. So the change is £39. And so it's just 39 over 260 times 100. Yeah. So you don't even have to do any of the other stuff. It's just, yeah, the change. They gave you the change. That would be if the new price was 39. Yeah. But they told us to change. How would you do this? And calculator one. Just tell me what you put in your calculator.
I'd do 44.79 divided by 3 and then times it by 8.
Correct. That's fine. Okay. Try this one.
So here do I need to do 6,000 times 1.03 to the power of something?
Yeah, and they call it n. That's it. So that's the first one of those that you got fully right first time. So we're getting there, and they're surprisingly common. Okay, what's the working out for this one?
So would you just do 60,000 times 1.12?
0.12, that's it. How do we do this?
So you get the denominators like common and you add it together. So it'd be like well, off the top of my head, I'm pretty sure the only one I can think of is like 40 right now. So.
And what will always work will be if you times the two together. It won't necessarily be the lowest common denominator, but it will give you a common denominator.
Yeah. And then on the left bit it will be 16 over 40, and then on the right bit it will be 15. I think, yeah. And then you add it together, and that'll give you 31 over 40.
That's it.
And I think that's simplest, yeah. Yeah.
Yeah, that's weird. Give your answer in its simplest form, but it is. Okay. Tricking us. So fine. Take away, same thing. Okay. Alright, how about this one?
Yeah, I think she is right because so 15 times 4 equals to 60,
Alright.
and and 60 bigger than 51.
Yeah, 60 is greater than 51. I'm not quite sure. So 15 over 60 is a quarter, and 15 over 60 is less than 15 over 51. Something like that. So finding a quarter of 51, that's a different way to do it. You find a quarter of 51 and say 12.75 or 13 compared to 15. 15 times 4, 60 and 51. Yeah, your method's there. Okay, how do we do top one?
So
it's kind of printed a bit weird. It should be like that.
So would you do 28? So we're over 7 times 28 over 1. Oh no, wait. So
Yeah, nothing wrong with that. If you wanted to do it that way.
and then would it be like 84 over 7 or something?
True. So 3 times 28 over 7 times 1, let's say. You can Bidmas, you can divide and multiply in any order. Is there anything there you can divide?
So 28 divided by 7,
Yeah.
and that would be 4.
Yeah. 28 over 7 is the same as 4 over 1 or 4. And so what answer do we get?
12.
That's 12. And then a different way would be 28 divided by 7 times by 3. Same thing. But this method, yeah, you can adding and subtracting, although Bidmas has them in a certain order, because they're the opposites, it doesn't matter what order you do those two in. Adding, subtracting, multiplying, dividing, you can do in any order. So long as they have times between them, you can cancel down. If they had plus or minus between them, you wouldn't be able to. They'd have to all cancel. Part C.
Like, will I just be allowed to use a calculator in the exam?
Estimate.
Oh, right. So would that be like 19? No, 19.9. To have to do like 20
Yes.
and 202.
No. 200.
200. And then that would be like 4,000.
Yeah, 4 and 3 zeros. Yes, so estimate means round the question figures to one significant figure.
Okay.
So one number that is not 0. That's what it means. Okay. How do we do this?
Would you do like 60 times 0.4?
And so this is non-calc. So how would you get the answer, or what would the answer be?
So is it 24?
Yeah, 24. And another way might be to say like 10% equals £6, and so 40% is 6 times 4. Or in a different way, it would be 60 divided by 10 times by 4. So many different ways. So that won't give you any trouble. That one we did. How do we do this one?
So in the maths test, so 32 over 80 times 100, and then when you work out what that is, do you just see if that percentage is higher than the English percentage?
Yeah, and how would you do this? Because it's non-calc.
So 3. So you have to do like 100 over 1.
Yeah.
So is it like 3,200 over 80?
So that's if you multiply it then divided. It might be easier to divide first, multiply second.
Alright, so
And you can imagine that these are all in one fraction together with times between them. Because that's what's going to happen in the next step. Anything you can do, divide the top and bottom by?
32 divided by 1.
How about 100 over 80? Can you simplify that?
To like 10 over 8.
So that's the obvious thing, yeah. Can you make things simpler?
Yeah, and then I'll go to like 5 over 2.
So you halved 10.
Yeah, 4, sorry.
Okay. Anything else?
And then it'll be like 32. You got 4. So yeah, so could you do 8 and 1?
Yeah.
And then are you just left with 40 over 1?
Yeah. And what's that?
40%. So yeah, that's 40%, isn't it?
Yeah.
And so she got a high percentage in math.
That's it. Do you find this method easier, like cancelling down to simple numbers, or like the 3,200 divided by 81 easier?
Probably 3,200 divided by 81.
Okay, so if you're more comfortable with that, then do it that way. So most people are more comfortable the other way.
Oh, so I just want to confirm something.
Yeah.
So for the GCSE, the papers are like both calculator, aren't they?
Which exam board are you doing again?
I'm pretty sure it's like EdXL or something.
I believe that there's one non-calc and two calc, that it's 3 papers in total. Am I crazy?
I think that's there's another GCSE like that, but we're doing the 2 calculator ones.
Okay. So that's Edexcel 2 calc papers. Edexcel 2 calc papers. Okay, I'll look into it, but all right. So if you're doing calc, then that's grand.
Okay.
Let's use calc method. This one will be fine. Okay, how do we do this one?
So could you just do here 60 over 68 times 100, and then just like take it away from 100, the answer?
Yeah. 68 times 100, and you could do 100%, take away that. Or a more direct way might be 8 over 68 times 100, which you get from the working out 68. So to give you the change, 68 minus 60 over 68 times 100. Yeah, that's fine. Just want to take a quick look. Yeah. So, okay, and then it's ratio, fine. Just want to see if there's anything we need to recap here. Ooh, that's too far back. Yes. Okay. Fine for those. So, no. Okay. So that's just 2-way table. Okay. And then 2 marker. How would you do this one? What's the working out?
So is it 27,500 times? I don't want to do like the same mistake again. Is it like times 0.8 to the power of something to get to 11,264?
Correct. That's because it depreciates. What if it appreciates?
What would you do? 227,500 times 1.2 to the n.
Yes, and that equals whatever. Okay, so that's good. Okay, how was that for you, Andrey?
Yeah, that was good, thank you.
So I'm gonna just look into the 2Calc paper stuff just to make sure. So yes, and continue this next time. Okay, so we're into the 2 mark questions. There's a lot for number, and you can see how we're kind of skipping through a lot because you already know them. Any questions for me in general?
I don't think so.
Okay, well done, Andrey. You're doing great, and I look forward to talking again next time.